Good evening, everyone. My name is Captain DeLazzer. I'm here to talk to you about some algebraic proofs today. Buckle up.
We're going to start this lesson by talking about some properties that you learned in algebra that we are now going to use today in geometry. So first we're going to talk about some properties of addition. The first property of addition would be the commutative property of addition. And what that says is a plus b is equal to b plus a, which means that it doesn't matter what order you add two things together. You will get the same answer either way. So for our example, you see 3 plus 5 is equal to 8, and 5 plus 3 is still equal to 8. These things equal each other because it doesn't matter which order you add them together by the commutative property of addition. The associative property of addition says the quantity a plus b plus c is equal to a plus the quantity b plus c. So when you see the associative property, in this case of addition, what it's going to do is it's going to change the grouping symbols. So instead of the grouping symbols, our parentheses being on the quantity a plus b, we change them to the quantity b plus c. And what it says is that it doesn't matter whether you add together a plus b before adding c, or adding b plus c first and then adding a. You should get the same answer either way because it's all addition. Over here you see the quantity 2 plus 3 plus 4. What is that? Well, 2 plus 3, we have to do parentheses first, so that's going to give you 5, plus 4 is 9. Over here, we have to do parentheses first, so 3 plus 4 is going to give you 7, plus 2 is 9. So you get the same answer either way by the associative property of addition. The identity property of addition says if you have 0 plus some variable a, it's still equal to a. So 0 plus anything is that same anything. 0 plus a number is equal to that number. So in this case, 5 plus 0 is equal to 5 by the identity property of addition. The inverse property of addition, or additive inverse, as some people call it, says that a plus negative a is equal to 0. And all this is saying is that if you add a number to its inverse or to its opposite, you get 0. They cancel each other out. For our example, we have 6 plus negative 6 is equal to 0, right? The 6 and the negative 6 just cancel each other out by the inverse property of addition. Now let's talk about some properties of multiplication. So the first property of multiplication, again, we start with the commutative property, which says if you have two numbers being multiplied together, a times b, it's exactly the same as if you were to flip those two numbers, b times a. You should get the same answer either way because the commutative property allows you to change the order in which you multiply things together as long as it's all multiplication. So here, for our example, you see 3 times 5, that's 15. 5 times 3, it's still 15, and we switch the order, so it doesn't matter as long as it's all multiplication by the commutative property of multiplication. The associative property of multiplication. Again, associative, that should be a key word in your head, and you think, oh, that's going to talk about grouping symbols. So here we see, yeah, our parentheses are the things that are changing because it's the associative property. But this time, it's the associative property of multiplication. So we have the quantity, a times b times c, is equal to a times the quantity, b times c. And again, all this is saying is that since it's all multiplication, it doesn't matter whether you multiply the a times b first and then multiply the c, or if you multiply the b times c first and then multiply the a. You'll get the same answer either way. And for our example over here, 2 times 3 is going to give you 6, times 4 is going to give you 24. Over here, 3 times 4, because we have to do the parentheses first, 3 times 4 gives you 12, times 2 gives you 24. So you get the same answer either way by the associative property of multiplication. The identity property of multiplication says 1 times any number is equal to that same number. So remember, the identity property of addition said 0 plus a number is that same number. So the identity property of multiplication says 1 times a number is that same number. So identity property just means that when you multiply or add something, it doesn't change the number. It just stays the exact same number. So 1 times a is equal to a by the identity property of multiplication. For our example, you see 5 times 1 is equal to 5. Now the zero product property just says anything times 0 is equal to 0. So a times 0 is equal to 0. 6 times 0 is equal to 0. That's the zero product property of multiplication. Now the inverse property of multiplication, or multiplicative inverse, or reciprocal property of multiplication, says if you multiply a number by its reciprocal. Remember, a reciprocal is just where you flip the fraction. So a over 1, that's what a is. The reciprocal of that would be 1 over a. Negative 2 over 1. The reciprocal of that would be negative 1 over 2. So the inverse property of multiplication just says if you multiply a number by its reciprocal, that equals 1. So negative 2 times negative 1 over 2 is equal to 1. Remember, reciprocal doesn't mean you change the sign. It just means you flip the fraction. Now let's talk about some properties of all numbers. This doesn't matter whether it's addition or multiplication, it's just properties of all numbers. The first one would be the reflexive property, which is the common sense property. It just says A equals A. A number equals that same number. So 3 is equal to 3. We know that by the reflexive property. The symmetric property says if A equals B, then B equals A. It's symmetric. If something equals something else, then that something else equals that something. You just flip the equation. So over here, if 3 plus 1 is equal to 4, then we know 4 is equal to 3 plus 1. It makes sense. You just flip that equation. The transitive property. This comes up all the time. So if A equals B, and we know that B equals C, then we know that since they both equal B, that A has to also equal C by the transitive property. So for our example, if 1 plus 1 equals 2 and 0 plus 2 equals 2, then we know that 1 plus 1 has to equal 0 plus 2 because they both equal 2, and that checks out. Now, properties of equality. There are addition, subtraction, multiplication, and division properties of equality. All the properties of equality say is that whatever you do to one side of an equation, you must do to the other side. So if you've ever solved an equation, like over here, we have A plus 1 equals 5. If we want to solve this for A, how do we get A by itself? Well, we subtract 1 on both sides, right? And since you are subtracting from both sides the exact same thing, that is the subtraction property of equality. If you were to add the same thing to both sides of an equation, that's the addition property of equality. If you were to divide both sides of an equation by some number, that's the division property of equality. So it works for each operation. The addition property of equality, subtraction property of equality, multiplication property of equality, and the division property of equality. Again, just anytime you do the same thing to both sides of an equation.
Fasten those seatbelts. It's example time.
Now, example 1 says, name the property that each statement illustrates. So here we have the quantity 3 plus 4 plus 5 is equal to 3 plus the quantity 4 plus 5. Again, anytime you see grouping symbols and those grouping symbols change from one side of the equation to the other, you need to think about the associative property. So yes, this is going to be the associative property. But is it the associative property of addition or multiplication? Well, it looks like all addition to me, so that would be the associative property of addition. Part B, we have 3 times 5 is equal to 5 times 3. So here we are rearranging the order in which we are multiplying these two numbers. So instead of multiplying 3 times 5, we're multiplying 5 times 3. And again, anytime you change the order, you want to think about the commutative property. So in this case, since we are multiplying 3 times 5 and then changing it to multiplying 5 times 3, it would be the commutative property of multiplication. For part C, we have the quantity 6 times 7 times 12 is equal to 6 times the quantity 7 times 12. Again, anytime you see those grouping symbols, and those grouping symbols are changing locations, then you know that's going to be the associative property. And here, since it's all multiplication on both sides of the equation, we know that it has to be the associative property of multiplication. Part D, we have 8 is equal to 8. Anytime you have a number is equal to itself, that is the reflexive property. Part E, we have 10 times 1 is equal to 10. So we have a number times 1 is equal to that same number. So anytime you get the same number, you think, okay, that's the identity property. And in this case, since you're multiplying, and we're multiplying by 1, we know it's the identity property of multiplication. Part F, we have 3 times 0 is equal to 0. So a number times 0 is equal to 0. Anytime you have a number times 0 is equal to 0, that's the zero product property.
Straighten up and fly right. Time for a U-try.
Okay, so for part A, we have 11 times 1 over 11 is equal to 1. So anytime you have a number times its reciprocal is equal to 1, that's going to be the reciprocal property of multiplication, or we can also call that the inverse property of multiplication. Part B, we have 100 plus 0 is equal to 100. So we start with 100, we add 0, and we get 100. We get the same thing that we had over here. Anytime you get the same number, that would be an identity property. And since we're adding 0, that's going to be the identity property of addition. Part C, we have if 4 times 7 is equal to 28, then 28 is equal to 4 times 7. So if one thing equals something else, then that something else equals that one thing. So you're just flipping the equation. So it's the same thing on both sides. It's symmetric, therefore it's the symmetric property. Part D, we have 9 plus negative 9 is equal to 0. So we are adding these two things together. They are canceling each other out perfectly, and we are getting 0. So anytime you add two things, you add inverses or the opposites together. That would be the inverse property of addition, or additive inverse property. Part E, we have if 8 is equal to 5 plus 3 and 5 plus 3 is equal to 7 plus 1, then 8 is equal to 7 plus 1. So if A equals B and we know that B equals C, then A equals C. That's what it's telling you here. So this would be the transitive property. Part F, we have 8 plus x is equal to 7. And we are subtracting 8 on both sides of the equation to get x is equal to -1. We solved for x. Anytime you do something to both sides of an equation, that's a property of equality. And since we subtracted 8 on both sides, that would be the subtraction property of equality. Now let's quickly talk about two-column proofs. This is what we're going to do for most of this chapter. So two-column proofs are like Google Maps. You're going to start with your location, which is the given, and then your desired destination, what you want to prove. Then you're going to give step-by-step instructions, which are statements and reasons, on how you get to your destination. So you've done this before probably in algebra, where your teacher gives you an equation that you need to solve. And that is going to technically be your given. That's what you're given, the equation. But you need to solve it. You need to get x equals some number. That's going to be what you're trying to prove. That's the bottom of your statements. So your given is at the top. What you're trying to prove, x equals some number, that's going to be at the bottom. And then the steps that you take to solve that, like subtracting 3 on both sides or dividing both sides by 5, something like that, those are going to be your statements over here. The reason for those statements is what you're going to put over here. So the subtraction property of equality, the division property of equality, stuff like that. So I'll show you how this works. So example 2, we are given the equation, -5 times the quantity x plus 4 is equal to 70. And we are trying to prove that x is equal to -18. So in an algebraic proof, your given should be your first step, and what you're trying to prove, that x equals -18, that should be your last step. So let's start this. The very first thing you do is write your given as the first statement. And the reason for that is that it's given. You are given that -5 times the quantity x plus 4 is equal to 70. Then we are going to go about solving this, and we have to state every step that we take. You can't skip any steps. So let's start with the first thing that I would do here. What would you do to solve this? Well, there's two ways you could solve for x. The first would be to divide both sides of the equation by -5. That would cancel out this -5, and then over here you would divide this by -5. That would be the division property of equality. Or you could do what I do, and I could distribute the -5 to the x and to the 4. Now, when you are distributing something to each term within a set of parentheses, what property allows you to do that? That would be the distributive property. So now we can continue. How do I solve this for x? Well, I guess I would, since it's -20, I would add 20 to both sides of the equation. And when you do something to both sides of an equation, that's a property of equality. Since we're adding 20 to both sides, that would be the addition property of equality. Next, we need to actually simplify this. -20 plus 20, those are going to cancel each other out. And then 70 plus 20 is going to give you 90. Now, when you simplify an equation like that, you just need to write over here in your reasons, we simplified. Next, I need to solve for x. So how do I get x by itself? Well, I need to get rid of this -5, right? So to get rid of that, I divide both sides by -5. And when you do something to both sides of an equation, that's a property of equality. In this case, since we divided both sides by -5, that would be the division property of equality. Now all that's left is to simplify this. The -5 divided by -5, those are going to cancel each other out. And then 90 divided by -5 is going to give you -18. Again, all we did was simplify. So for your reason, just put simplify. Now example 3, we are given that 2x minus 13 is equal to -5, and we are trying to prove that x is equal to 4. So again, in an algebraic proof, the given should be your first step. What you're trying to prove, x is equal to 4, that should be your very last step. So our first step needs to be 2x minus 13 is equal to -5, and that's because it's given. Now we move on to step 2. How do I solve this for x? Because that's what we're trying to prove. X is equal to 4, so we got to get x by itself. How do we get x by itself? Well, since 2x minus 13 is equal to -5, to get rid of this -13, I'm going to add 13 to both sides of the equation. Anytime you do something to both sides of the equation, that's a property of equality. In this case, since you're adding 13 to both sides of the equation, that's the addition property of equality. Next, we need to simplify this. So -13 plus 13, those are going to cancel each other out. -5 plus 13, that's going to give you +8. Again, all we did was simplify, so your reasoning, what you would put over here would be simplify. Next, we need to get x by itself. So we have 2 times x is equal to 8. So how to get rid of this 2? I'm going to divide both sides of the equation by 2. Anytime you do something to both sides of an equation, that's a property of equality. And since here we are dividing both sides by 2, that's going to be the division property of equality. These 2's are then going to cancel each other out, and over here 8 divided by 2 is going to give you 4. So we are left with x is equal to 4, exactly what we're trying to prove. Perfect. Now what do I put over here for the reasoning? Well, I just simplified, right? I canceled out the 2's and then I did 8 divided by 2, so that is simplifying.
Time for you to try it. Don't buy it. That's what I say.
Okay, this time we are given -4 times the quantity x minus 3 plus 5x is equal to 24. We are trying to prove that x is equal to 12. Again, this is an algebraic proof because we're trying to solve an equation. So all we do, again, in an algebraic proof, the given needs to be your first step. What you're trying to prove, x is equal to 12, that needs to be your last step. So we start with our given. There it is. The reasoning, it's given. Next, we need to solve this for x. So the first thing that I would do in order to solve this for x, I would distribute this -4 to the x and to the -3. So -4 times x is going to be -4x. -4 times -3 is going to be positive 12. Now, what did I do? I distributed that -4. And what allows me to do that? What property allows me to distribute? That would be the distributive property. Next, I can do a couple different things. The first would be that I could subtract 12 from both sides of the equation. That's one thing I could do. The other would be that I can combine like terms. So I could take this 5x, add it to the -4x, and that would give me positive 1x. So what allows me to just simplify the equation up here? That would be simplifying. Next, I need to solve for x. So how do I get x by itself? I'm going to subtract 12 from both sides. Now, in order to subtract 12 from both sides, anytime you do the same thing to both sides of an equation, that's the property of equality. And since I subtracted 12 from both sides, that's the subtraction property of equality. So this equation, I can then simplify. 12 minus 12 is going to be 0. Those cancel each other out. And then 24 minus 12 is going to give me 12. So what did I do? I just simplified this equation. So my reason over here would be simplify. And because I have what I was trying to prove, I am done. Now, example 4 says write a 2-column proof. So it says if angle GHK is congruent to angle JHK, then x is equal to 19. So there's a couple differences I want to point out to you here. First, it says if angle GHK is congruent to angle JHK, then x is equal to 19. There's no given and there's no proof. Well, since we have an if-then statement that we are trying to write a 2-column proof for, the if part is going to be your given. The then part is going to be what you're trying to prove. So we have that. We have a given and we have what we're trying to prove. The next thing would be that we have this figure over here now. This figure, it's not like an equation like we usually have. We have an actual picture, a geometric figure over here. So what we're going to do is we're going to use this. In a geometric proof, which is what this is, we are going to have to first mark up our figure based on what we're given. That'll help us show what we're trying to prove. So it says if angle GHK is congruent to angle JHK, so GHK would be this angle right here, is congruent to angle JHK, so angle JHK. Oh, so it's saying that this angle right here is congruent to this angle right here. They're the same measure. So based on that, we can then prove that x is equal to 19. So we've marked up the figure. Now we're going to put our given. Remember, the given is the if part. So given that angle GHK is congruent to angle JHK, we're going to prove that x is equal to 19. So again, this is the given, so our reasoning would then be it's the given. Next, notice I start with a congruent sign, but I need to go to an equal sign. Here's how this works. Anytime you go from a congruent sign to an equal sign, or an equal sign to a congruent sign, you're going to write definition of congruent and then whatever your figure is. So here they are angles. So this is going to be the definition of congruent angles. So instead of writing angle GHK is congruent to angle JHK, we're going to write the measure of angle GHK is equal to the measure of angle JHK. And that, again, is by the definition of congruent angles. Notice that when you go from congruent sign to equal sign in angles, you need to write a little m out front. That's telling you the measure of angle GHK because we're talking about the degrees, the measure of that angle now, instead of just the shape itself. So now that I have successfully gone from congruent sign to equal sign, I can now plug in what the measure of each of these angles is equal to. So the measure of angle GHK we know is equal to x plus 26, so I can plug that in here. The measure of angle JHK is equal to 2x plus 7, so I can plug that in here. And anytime you plug something in or substitute something in, that's the substitution property. Here, what we can do next is we can solve for x, because that's what we're trying to do. So to solve this for x, there's multiple different ways you could solve this for x. You could subtract x on both sides. You could subtract 2x from both sides. You could subtract 26 from both sides. You could subtract 7 from both sides. I am going to subtract x from both sides of the equation. Anytime you do something to both sides of an equation, that's a property of equality. And since it's subtraction here, that would be the subtraction property of equality. Next, what we can do is we can simplify this. I can take x, subtract x, those cancel each other out. Over here, 2x minus 1x is going to be 1x, right? If you have 2x's, subtract 1x, you're left with 1x. So what did I do? I just simplified. So you write simplify. Next, how do I get x by itself? I'm going to subtract 7 from both sides. Since I did something to both sides, that's the property of equality. Since it was subtraction, it's going to be the subtraction property of equality. So 26 minus 7 is going to give me 19. And then 7 minus 7, those just cancel each other out. So I simplified this to get 19 is equal to x, which means I can just write simplify here. Now, you think you would be done here, but you are not. You do not have what you are trying to prove. You're trying to prove x is equal to 19, not that 19 is equal to x. So how do I simplify this? I need to flip these two things. So instead of writing 19 is equal to x, I'm going to write x is equal to 19. And what allows me to flip an equation like that? That would be the symmetric property. And you're done.
Go ahead and try this at home.
We are again writing a two-column proof. This time it says if the measure of AB is equal to the measure of CB, then x is equal to 4. So it's kind of nice. They didn't put a congruent sign, they put an equal sign, so we can skip that step. So the first step, this time it's a geometric proof because we have a little figure over here. So anytime you have a figure like this, you need to mark up what you're given. So it says if the measure of AB is equal to the measure of CB. So we are given that the measure of AB is equal to the measure of CB. So how do I mark that over here? Well, we know the measure of AB, this side of the triangle, has to be equal to the measure of CB, the measure of this side of the triangle. Oh, okay, so I can see how this is going to work. Since we know these two measures are equal to each other, we're eventually going to set these two expressions equal to one another and we can solve for x. Cool. So that's how we do this. So our next step would be to write our given. What are we given? Remember, that's the if part. The measure of AB is equal to the measure of CB, and that is given. Next, how do I end up getting x is equal to 4? Well, we said since we know each of these measures is equal to each other, we could just substitute in 3x plus 15 for the measure of AB and 5x plus 7 for the measure of CB. And when you substitute something in or plug something in, that's the substitution property. Next, what we can do is we can solve this for x. Again, there's a couple different ways you could do this. What I'm going to do first is I'm going to subtract 3x from both sides of the equation. Anytime you do something to both sides of an equation, that's a property of equality. Since we're subtracting, that's the subtraction property of equality. Now I need to simplify this equation. So 3x minus 3x, those cancel each other out. Over here, 5x minus 3x, that just becomes 2x. Again, anytime you simplify, you just write simplify. Next, I need to solve for x. So how do I get x by itself? I need to get rid of this plus 7. So I subtract 7 on both sides of the equation. Anytime you do something to both sides of an equation, that's a property of equality. And since here we're subtracting, that's the subtraction property of equality. Now I need to simplify this again. So 15 minus 7, that's going to give you 8. And then 7 minus 7, those are going to cancel each other out. So we get 8 is equal to 2x. Again, I just simplified this, so I write simplify. Next, I need to get x by itself, so I divide both sides by 2. Since I did it to both sides of an equation, that's a property of equality. And since I'm dividing both sides by 2, that's the division property of equality. Lastly, the 2's are going to cancel each other out. And 8 divided by 2 is just going to give me 4. So I get 4 is equal to x. And that was just by simplifying. But 4 equals x, that's not what I'm trying to prove. I'm trying to prove x is equal to 4. So how do I get x equals 4 from 4 equals x? Well, I just flip this equation. Why are you allowed to flip an equation? Because of the symmetric property. And now you are done.